Kubernetes makes it possible to containerize applications and simplifies deployment to production. Bogdan Stashuk will teach you everything you need to know to get started with Kubernetes.
Welcome to the Kubernetes for Beginners. Kubernetes is de facto standard for deployment of the containerized applications into production. Kubernetes is open source and therefore it is free for use. Let me first introduce myself before we will start this course. My name is Bogdan Stashuk and I've been using Docker and Kubernetes multiple years on practice, and I deployed real-world applications into production using Kubernetes. Also, I'm teaching online, and on my personal website stashuk.com you could find all courses which I teach. Now let's get started with Kubernetes for Beginners. And I would like to start with course plan. So what is included in this course? We will start by talking about terminology and the key features of the Kubernetes. And you'll learn what is Kubernetes cluster, what is node, and what is pod, and what Kubernetes essentially does. Afterwards, we will immediately dive into the practice and we will build small Kubernetes cluster locally on our computers. And afterwards, using such cluster, we will create and scale different deployments. Also, we will build custom Docker image, push it to Docker Hub, and afterwards create Kubernetes deployment based on this customly built Docker image. Other than that, we will also create services and deployments in Kubernetes using YAML configuration files. Also, we will connect different deployments together, because it's a very common situation when you have to connect different applications together over their network. And Kubernetes allows, of course, to do that. And also, finally, we will change container runtime from the Docker to CRI-O, because Kubernetes is not bound to Docker. It also supports other container runtimes like CRI-O and Containerd. And you could use Kubernetes absolutely without Docker. One single prerequisite for this course is your familiarity with Docker. I assume that you know what is Docker container and how to create different containers. Alright, so let's get started with this course. And I would like to start with definition. Kubernetes is container orchestration system. Using Docker, you could of course create container on any computer. But of course, if you want to create multiple containers on different computers, on different servers, you could get into the troubles. Kubernetes allows you to create containers on different servers, either physical or virtual, and all of that is done automatically without your intervention. You just tell Kubernetes how many containers you would like to create based on a specific image. Kubernetes is a relatively long word and it consists of 10 different letters. But IT professionals and software developers are relatively lazy people and they don't like to type much. That's why such a long word is usually shortened just to 3 characters. But how is it done? Let's have a look at this word. Between K and S there are actually 8 different letters. So number 8. That's why long word Kubernetes could be shortened just to 3 characters. K, 8, S. So 8 represents simply quantity of the letters between starting and ending letter. Simple as that. Knowing this very simple trick, we could go on, and now let me explain to you what Kubernetes takes care of. So Kubernetes takes care of automatic deployment of the containerized applications across different servers. And those servers could be either bare metal or physical servers or virtual servers. Virtual servers option is of course more common nowadays, and almost no one uses now bare metal servers. So Kubernetes allows you to perform automated deployments across different servers that could be located even in different parts of the world. Other than that, Kubernetes also takes care of distribution of the load across those multiple servers. And this allows you to use your resources efficiently. and avoid underutilization or overutilization of the resources. Also, Kubernetes takes care of the auto-scaling of the deployed applications in case you need to increase, for example, quantity of the containers which have to be created on different servers. And all of that done automatically. You just tell when you want to scale up or down. Also, Kubernetes takes care of the monitoring and health check of the containers. And in case some containers fail for some reasons, Kubernetes could automatically replace failed containers. And all of that done without your intervention. As I just told you, Kubernetes deploys containerized applications, and therefore it has to use specific container runtime. And Docker is just one of the possible options. Kubernetes nowadays supports such container runtimes: Docker, CRI-O, and Containerd. And such container runtime, for example, as Docker or CRI-O, must be running on each of the servers which are included in the Kubernetes cluster. And main outcome here is that Kubernetes could be utilized even without Docker at all. It supports other container runtimes like CRI-O and Containerd. And at the end of this course, I'll demonstrate to you how to change container runtime and move from Docker, for example, to CRI-O. So, now let's get started with terminology and architecture of Kubernetes. And let's start with pod. Pod is the smallest unit in the Kubernetes world. In Docker world, container is smallest unit. In Kubernetes, pod is the smallest possible unit. And containers are created inside of the pod. So pod anatomy is following. Inside of the pod, there could be containers, either one or even several containers. Also, there are shared volumes and shared network resources, for example, shared IP address. This means that all containers inside of the same pod share volumes and share IP address. And you must keep that in mind if you want to create multiple containers inside of the same pod. Most common scenario, of course, is to have just single container per pod, but sometimes when containers have to be tightened together and they heavily depend on each other and they could exist in the same namespace, it is possible to create several containers in the same pod. But again, single container per pod is the most common use case. Also, please keep in mind that each pod must be located on the same server. It is not possible to spread containers from one pod across different servers in the Kubernetes cluster. One pod, one server. So let's now have a look at the Kubernetes cluster. What is that? Kubernetes cluster consists of nodes. Node is actually server, either bare metal server or virtual server. And you could include multiple such servers into the Kubernetes cluster, and they could be located in different data centers in different parts of the world. But usually nodes which belong to the same Kubernetes cluster are located close to each other in order to perform all jobs more efficiently. Inside of the node there are pods. Pod is again the smallest possible unit in the Kubernetes. And inside of each pod there are containers, usually single container per pod. And such pods are created on different nodes. And all of that is done automatically for you. Kubernetes does this job. But of course, your job is to create such nodes and create cluster based on those nodes. Nodes will not automatically form cluster without your intervention. But after such initial configuration, everything will be automated, and Kubernetes will automatically deploy pods on different nodes. But how those nodes actually communicate with each other and how are they managed? In Kubernetes cluster, there is master node. And other nodes in the cluster are called worker nodes. And master node actually manages worker nodes. And it's master node's job to distribute, for example, load across other worker nodes. And all pods which are related to your applications are deployed on worker nodes. Master node runs only system pods, which are responsible for actual work of the Kubernetes cluster in general. We could also say that master node in the Kubernetes cluster is actually control plane, and it does not run your client applications. So, which services actually run on different nodes? Let's have a look at this diagram. There are such services as kubelet, kubeproxy, and container runtime, and those services are present on each node in the Kubernetes cluster. You already know what is container runtime. Container runtime runs actual containers inside of each node. And there are such container runtimes as Docker, CRI-O, or Containerd. There is also such service as kubelet, and such service on each worker node communicates with API server service on the master node. API server service is the main point of communication between different nodes in the Kubernetes world. Kubeproxy, which is present on each node as well, is responsible for network communication inside of each node and between nodes. Also, there are other services which are present on master node, and they are scheduler, and such service is responsible for planning and distribution of the load between different nodes in the cluster. Also, there is kube controller manager, and it is single point which controls everything actually in the Kubernetes cluster, and it controls actually what happens on each of the nodes in the cluster. Also, there is cloud controller manager, and its job is interaction with cloud service provider where you actually run your Kubernetes cluster. Because usually you don't create such clusters yourself using just your own servers. Instead, you could very easily rent a Kubernetes cluster from one of the cloud providers, which actually perform almost automated creation of all nodes and the connections between such nodes. And for that, you have to run Cloud Controller Manager service on the master node. Also, for example, if you want to create the deployment of your application inside of the Kubernetes cluster, which will be opened to outside world and allow connections from outside, you could create also load balancer IP addresses, and those load balancers IP addresses are usually provided by specific cloud providers. Also on master node there is such service as etcd, and this is a service which actually stores all logs related to operation of entire Kubernetes cluster, and such logs are stored there as key value pairs. Also, there are other services which are running on master node, for example, DNS service, which is responsible for names resolution in entire Kubernetes cluster. And for instance, using a DNS service, you could connect to specific deployment by the name of the corresponding deployment service. And in such way, you could connect different deployments with each other. These are different services which are running on different nodes in the Kubernetes cluster. And the main service on the master node is API server. And by the way, using this API server service, you could actually manage entire Kubernetes cluster. How is it done? It is done by using kubectl or kube control. And kube control is separate command line tool which allows you to connect to specific Kubernetes cluster and manage it remotely. And kubectl could be running even on your local computer, and using such kubectl tool you could manage remote Kubernetes cluster. And using such tool, you actually connect using REST API to API server service on the master node. And such communication happens over HTTPS. By the way, other nodes in the cluster, I mean worker nodes, communicate with master node in the same fashion. It means that using such a kubectl tool, you could manage any remote Kubernetes cluster. That's it for Kubernetes architecture overview, and now you know that the Kubernetes cluster consists of the nodes, and one of the nodes is master node, and it manages other nodes which are called worker nodes. On each node there are pods, and pods are created automatically by Kubernetes, and inside of the pod there are containers, usually just single container per pod. Also, please keep in mind that all containers inside of the pod share namespaces of that pod, like volumes or network IP address. Also, pods are smallest units in Kubernetes, and the pods could be created, could be removed, could be moved from one node to another. This happens automatically without your intervention. But you have to design your application with this in mind. Pods could be deleted on any moment of time. Also, there are different services which are running on different nodes. For example, API server service is central point of communication between master node and other worker nodes. And also using such API server service, you actually could manage actual Kubernetes cluster using kubectl tool, which has to be installed, for example, on your computer if you perform management from your computer. Alright, I don't want to dive deeper into the details of the Kubernetes because this is very complicated tool, and I want to focus more on practical tasks instead. That's why now, after such overview, we will dive together with you into the practice and perform different practical tasks together. For example, we will create deployments, services, scale deployments, create custom Docker image and create a deployment based on that image, and so on. In order to perform all practical tasks together with me, you have to install some programs on your computer. And now let me talk about required software. And first, we have to create actual Kubernetes cluster, where we will create different deployments. Of course, you could create cluster using services from one of the cloud providers, like Amazon Web Services or Google Cloud. But you have to pay for such service. If you want free solution, you could create cluster locally on your computer, and for that there is such tool as Minikube. And such tool will essentially create just a single node cluster, and this node will be both worker node and master node. But for test deployments and as a playground, it works pretty nice, and all of that is free and will be running on your local computer. In order to run Minikube successfully, you have to utilize virtual machine or container manager. And there are following virtual machine or container managers which are supported: VirtualBox, VMware, Docker, Hyper-V, or Parallels. There are also other options available, but you have to utilize one of such options in order to actually create a virtual node which will run all pods in your Kubernetes cluster. I suggest you to go ahead with Hyper-V if you are a Windows user, and if you are a Mac OS user, you could go ahead with VirtualBox. It is free and open source, or you could utilize VMware or Parallels. By the way, there is also an option to run Minikube as a container inside of the Docker. Of course, if you have Docker already installed on your computer, you could utilize it in order to create Kubernetes cluster using Minikube. And essentially, it will create a separate Docker container, and inside of that container, all pods will be created. But I personally don't recommend to you to go ahead with Docker option because there are some limitations. For example, I was not able to change container runtime inside of the Docker container to CRI or container D. And therefore, I recommend to you to go ahead with other options which I mentioned here. By the way, Hyper-V is available on Windows computers out of the box, and you could utilize it as virtual machine manager for running Minikube node. To summarize, using Minikube, you will create single node Kubernetes cluster, but as I mentioned before, you have to use specific tool in order to manage this cluster. And this tool is called kubectl. By the way, kubectl is included in Minikube, but if you want to use such included version, you have to enter minikube kubectl commands. It is not convenient, therefore I recommend to you to install kubectl separately. And using separate installation, you will be able, of course, to manage other Kubernetes clusters which are located, for example, at Amazon Web Services. So kubectl is also one of the programs which you have to install on your computer. Certainly, I'll explain to you how to install Minikube and kubectl. Other than that, we will also do some coding in this practical course, and for that you have to use one of the code editors, and I recommend to you to install Visual Studio Code. It is open source and free for use, and if you have not yet installed it, please go ahead and install it. Also, it has many different extensions, and one of them is Kubernetes extension, and using such extension you could very fast create, for instance, YAML configuration files for your deployments and services in Kubernetes. That's all what you need for this course: Minikube, kubectl and Visual Studio Code. Now let's get started with practical part, and I hope you'll enjoy this course. And we will start with the installation of the Minikube and kubectl. Alright guys, now let's get started with practical part of the course, and we will start by installing Minikube along with kubectl. But first I would like to ask you to navigate to kubernetes.io. This is the main site dedicated to Kubernetes in general, and it has all documentation related to configuration of the Minikube clusters, creation of the deployments, etc. Please click here on documentation, and here in the left section go to getting started. And here you could read how you could create learning environment. Along with that, you could also find information how to create production environment. But we are interested now in creation of the local Kubernetes cluster, and for that we will utilize Minikube. And also we will install kubectl. That's why please click here on this hyperlink Install Tools, and you'll find instructions how to install kubectl on different operating systems. Please choose yours. I'll choose macOS here. And if you're a macOS user, you could very easily install kubectl using Homebrew. Let me demonstrate to you how to do that. Let me click on this option. Run the installation command brew install kubectl. Let me copy this command and open up terminal. I'm using iterm2 on Mac, and paste this command here. Let's go ahead and install kubectl. Downloading package. And kubectl was installed. Let me check version of the kubectl. For that I could utilize this command kubectl version -- client. Let me enter it here. And I see that the kubectl was installed successfully, and here is client version major 1 and minor 22. And here is actually exact version which was installed. Alright, if you're a Windows user, I recommend to you to install kubectl using Package Manager. You could go to Install and Set up kubectl on Windows, and here choose option Install on Windows using Chocolatey or Scoop. Click on this option, and here you'll find instructions how to install different packages using Chocolatey Package Manager or Scoop command line installer. I recommend to you to install Chocolatey Package Manager. In order to do that, please open up this link here and find instructions how to install this package manager for Windows. Using the same package manager, you could very easily install Minikube as well. So please go ahead and install this package manager, and afterwards follow those instructions on how to install kubectl on Windows. Use just single command this one, and afterwards verify that kubectl is available using this command. Alright, after this I assume that kubectl is already available on your computers, and now let's go ahead and install Minikube. Go back to Getting Started page, and here scroll down to Learning Environment and click on Hyperlink Install Tools, this one. You'll find again that you have to install kubectl, that's what we just did together. And if you scroll down, you'll find options which you could utilize in order to create a local Kubernetes cluster for learning and testing purposes. Nowadays, there are such tools as Kind, and it allows you to create Kubernetes cluster locally on your computer, but it requires Docker. Also, there is Minikube and kubeadm. We will utilize Minikube throughout this course. That's why let's get started with installation of the Minikube. It does not require Docker, but it does require one of the virtual machine managers like Hyper-V, Parallels, or if you want, you could also utilize Docker. Please navigate to this link, Minikube. You could simply enter Minikube in the Google search bar and click on the first result in the output, and here you'll find documentation how to get started with Minikube. Please click on this link, Get Started, and here you could read about Minikube, and it will basically create a Kubernetes cluster locally on your computer, and it will contain just a single node which will act both as master node and worker node. And all what you need in order to create such a cluster is just single command minikube start. Simple as that. But in order to successfully create a Minikube cluster, you have to install one of the container or virtual machine managers, such as Docker, HyperKit, Hyper-V, Parallels, and so on. I told you before that if you're a Windows user, I recommend to you to utilize Hyper-V because it is available on Windows out of the box. If you are a Mac user, I recommend to you to go ahead either with VirtualBox option or Parallels or VMware Fusion. VirtualBox is free for use, therefore, if you don't want to pay anything for Virtual Machine Manager, I recommend you to go ahead with this option. Also, it is possible to create Minikube cluster inside of the container, Docker container, and for that you could just install Docker, but I personally don't recommend to you to go ahead with this option because there are some limitations in running such a cluster inside of the Docker container. Alright, here below you could find out how to install Minikube on different operating systems, Linux, Mac OS and Windows. If you are a Windows user, you could similarly as with kubectl utilize Chocolati. Please select this option and enter just single command choco install Minikube, simple as that, and you'll get Minikube installed on Windows computer. But I'm using Mac OS, that's why I'll select this option and select Homebrew. And in order to install Minikube using brew, I could simply enter just one command, brew install Minikube. Let me go ahead and install it using brew. Let's go back to terminal and here paste command brew install Minikube. Let's wait a bit until it is installed. Alright, Minikube was installed and now I could verify its version, Minikube version. Here is version in my case, and you could also enter Minikube help command in order to find the list of all available commands in Minikube. And if you scroll up, you'll find out how to start local Kubernetes cluster, get status of the local Kubernetes cluster, stop cluster, delete, and open dashboard. Also, you could pause and unpause Kubernetes cluster. Great. Now let's create the actual cluster. I assume that now you have also installed Minikube and kubectl. Those tools are two separate tools. That's why they are available as two separate commands, Minikube and kubectl. And now let's go ahead and create Kubernetes cluster. For that, please utilize command minikube start. But first, let's enter Minikube status in order to check current status of the cluster. Minikube status. Here I see that profile Minikube not found, run Minikube profile list to view all profiles, and also I see that in order to start cluster, I have to run Minikube start command. That's what we are about to do right now. Let's create cluster Minikube start. And here I would like to ask you to start Minikube cluster with option. And this option will be driver. And you should write it with 2 dashes, dash dash driver. And here will be equal sign, and after it you have to specify virtual machine or container manager which you would utilize in order to create Minikube cluster. I mentioned before that if you are a Windows user, I recommend to you to use Hyper-V. Therefore, if you are on Windows, simply enter here Hyper-V, like that. All lowercase without dash. Dash dash driver equal sign Hyper-V. If you are a macOS user, you could go ahead with any of those options, VirtualBox, Parallels or VMware Fusion. I will utilize VirtualBox. If you don't have VirtualBox, please go ahead and install it. Enter here VirtualBox and click on the first link here. VirtualBox is free, and here is a link where you could download VirtualBox. So if you don't have VirtualBox and if you are a macOS user, please go ahead and download VirtualBox. Great. I already have VirtualBox installed, that's why I will simply specify it as a value for the driver option here. So I'll type VirtualBox. Let's go ahead and create Minikube cluster inside of the VirtualBox virtual machine in my case. Creating VirtualBox virtual machine, quantity of CPUs, memory and disk. It will take a while, let me wait a bit. Virtual machine was created and now I see message preparing Kubernetes on Docker, and it means that by default we will utilize Docker container runtime for running actual containers inside of the Kubernetes cluster. Here I see step generating certificates and keys, booting up control plane. And finally at the end I see done, kubectl is now configured to use Minikube cluster. And it means that you don't need to do anything in order to connect from kubectl to actual Minikube cluster. This connection was created automatically for you during creation of the Minikube cluster. Also, in my case, I see such a warning. You have selected VirtualBox driver, but there are better options. For better performance and support, consider using a different driver, HyperKit, Parallels or VMware. Now let's actually verify status of this Kubernetes cluster, and for that you could enter command minikube status. And you should find out that host is running, kubelet is running, API server is running, and kubeconfig is configured. That's normal status of the Minikube cluster, and now we are actually able to create deployments, services, etc. inside of this Minikube cluster. Also, I would like to mention that I don't have Docker running right now. I actually have it installed on this computer, but over here in the icons bar, I don't see Docker icon. It means that now Kubernetes on my local computer does not utilize actual Docker installation on my computer. But there is Docker which is running inside of the Minikube node. And that's what we will check right now. So, as you already know, each node in the Kubernetes cluster is just server, either virtual or physical. In our case, we have created virtual server, and you could connect to any server by using SSH protocol. And in order to connect via SSH, we first need to find out which IP address was assigned to Kubernetes node. Minikube provides command for that. Simply type minikube IP, and you'll see which IP address was assigned to virtual machine which is running our Kubernetes node, which was created by Minikube. Here is IP address in my case. Simply grab this IP address and afterwards type SSH docker. It is username, which is default username for such a node, such virtual server, and after @ sign, paste IP address of Minikube node. And afterwards, please press Enter. You will be presented with fingerprint. Please go ahead and type here yes, we trust such a fingerprint. And afterwards you will be prompted for password. Default password for Minikube virtual machine is tcuser. Please go ahead and type it here. So username is Docker and password is tcuser. Password was entered and now I see welcome prompt from the Minikube server. Now I am inside of the Kubernetes node. And first command which I would like to ask you to enter here is docker ps. Such command will list you all running Docker containers. And here are a bunch of different containers which were created inside of the Kubernetes node. And again, please recap that Docker is default container runtime for Kubernetes. There are other container runtimes such as CRI-O and Containerd. But here we see that there are a bunch of different containers which were created by Docker inside of the Minikube node. And for instance, here I see such container as Kube API Server, Kube Scheduler, and so on. Recap that we discussed with you different services which are running on master nodes and worker nodes. And those services are actually running inside of the containers, as you see right now here. Also, there are such containers as the Kube Proxy, Storage Provisioner, or, for instance, Core DNS. And again, every container has its own purpose. That's how you could verify which containers were created inside of the Kubernetes node. But if I enter here kubectl command, I'll see error kubectl command not found, because kubectl command is not available inside of the Kubernetes node. kubectl is external tool which is used in order to manage Kubernetes cluster. That's why let's now go out of this SSH connection. Connection was closed. And now let's utilize kubectl command here. Of course, kubectl is available locally on our computers because we have installed kubectl before. Let's first check cluster info. kubectl cluster-info. And I get following output. Kubernetes control plane is running, and here I see IP address which we just saw after entering Minikube IP command. In your case, of course, such IP address will be different. And also I see that Core DNS service is running as well. It means that now we are able actually to create deployments, services, etc. on our Kubernetes cluster. But first, let's list nodes which are available in our Kubernetes cluster. For that, please enter command kubectl get nodes. And here I see just single node, because Minikube creates single node cluster. Here is name of such node, status is ready, and here are roles, control plane and master. Recap that now inside of our Minikube cluster, this single node acts both as master node and worker node. And on worker node, Kubernetes creates different pods related to your deployments, which you deploy in the Kubernetes cluster. Now let me check which pods are available right now in this cluster. For that, let's enter command kubectl get pods. And now I see output no resources found in default namespace. Let's list all namespaces which are available now in this Kubernetes cluster. For that, please enter command kubectl get namespaces. Like that. And I see several namespaces like default, kube node lease, kube public, and kube system. Namespaces are used in Kubernetes in order to group different resources and configuration objects. And if you enter simply kubectl get pods, you will see only pods available inside of the default namespace here. And by the way, all pods which we will create throughout this course will be created in default namespace. But we have not yet created any pods so far. That's why let's try to find out which pods are running inside of other namespaces, for instance kube system. In order to list pods in specific namespace, you have to utilize namespace option. So kubectl get pods -- namespace equal sign, and here enter kube system. Let's go ahead and run this command. And now here in this namespace kube system, I see such pods as core DNS, etcd, which stores logs of entire Kubernetes cluster, kube API server, kube controller, kube proxy, kube scheduler, and storage provisioner. All those pods are system pods which are running on this master node. Alright, that's how we could find out which pods are running right now in our Kubernetes cluster. Now let's go ahead and create pod manually. And for that we could utilize command which is similar to docker run command, but with docker run command you could create just single Docker container. Here you could utilize kubectl run command in order to create just single pod. Let's do that. Kubectl run. Here will be name. Let's for instance utilize nginx docker image, which is available at Docker Hub. For that, let's enter here name of the pod, nginx, and afterwards let's add option image, and its value will be nginx. Nginx here is name of the Docker image, which will be pulled automatically, and a new container will be created based on this image, and this container will be running inside of the Kubernetes pod. Let's go ahead and see what will happen. Kubectl run nginx -- image equal sign nginx. And here I see output pod nginx created. Let's enter command kubectl get pods. And here I see now single pod nginx. It is not yet ready, and its status is container creating. Let's enter same command again, kubectl get pods, and now I see that this pod is now running. It is ready and its status is running. Of course, it took some time in order to create such a pod, because inside of it there is nginx container, and Docker inside of the Kubernetes node was actually requested to pull nginx image from Docker Hub and create corresponding container based on such image, nginx. Let's now find out details of this specific pod with name nginx. This name we specified manually here. For that, please enter command kubectl describe pod, and here will be name of the pod which you would like to describe, get details about. Here will be nginx, it is name of the running pod. And here are many different details related to this specific pod. Let me scroll a bit up, and here I'll find out such information as namespace this pod belongs to, and it was automatically assigned to default namespace. That's why we were able to see it in the list when we entered command kubectl get pods, because such command lists all pods inside of the default namespace. Here is information about node where such specific pod was created. Recap that Kubernetes automatically distributes load across all nodes, worker nodes inside of the cluster, and it selects specific node for specific pod. And that's information about the node where this particular pod was created. In our single node cluster, of course, you will see the same node each time when you create any pod. And here is IP address of such node. Here is start time, here are labels, status is running, and here is IP address which was assigned to this particular pod, 172.17.03. But please note that now we will not be able to connect to this particular pod using such internal IP address of the pod. In order to be able to connect to pods, you have to create services in Kubernetes, and that's what we will look at a bit later. Here below you could also find out which containers were created inside of this pod, and there is just a single container. Here is ID of such container. Here is long ID. Here is image which was utilized for this particular container. And that's that image which we specified using --image option when we created new pod. Here is image ID, and it is ID of the image from the Docker Hub, because by default Kubernetes pulls all images from the Docker Hub. Of course, it's possible to configure Kubernetes to pull images from other repository hosting services, but default is Docker Hub. Alright, these are details about this particular pod. And we find out that there is IP address assigned to this pod. There is container which was created inside of this pod, and here are logs related to creation of this particular pod. You see that this particular pod was successfully assigned to Minikube node. Here is message about pulling image nginx from the Docker Hub, successfully pulled image, created container nginx, and started container nginx. And it means that now there is nginx container running inside of the created pod. Again, you could find the list of all pods by entering command kubectl get pods. And here is single pod available right now in the default namespace. Now, let's quickly go back again inside of the Kubernetes Minikube node and list again Docker containers. And we will find out that now there is one more container which was created in the nginx pod. So, using up arrow, I could go back to the SSH command which I entered before, here it is, and connect to this node again. Enter tc user password, and let's enter here docker ps, but now let's filter output by name nginx. And now I'll find out that there are two different containers. Here is first one and here is second one, which are related to nginx. Here is name of the first container, k8s nginx, nginx default, and so on. And also there is one more container, k8s pod, nginx default, and so on. And this second container is called pause container. Here you see that inside of the container, pause executable was actually launched when container was created. And if Docker is a container runtime in Kubernetes, there are always such pause containers, which are created for each specific pod. And such pause containers are created in order to, let's say, lock namespace of specific pod. And we discussed before that all containers inside of the same pod actually share namespaces. And this container, which is actually running our nginx web server, could be stopped, could be recreated by Kubernetes, but pod remains untouched. And this second container, which is called pause container, is required to keep namespace of the pod. Alright, that's how containers look right now, and let's actually connect to this container where we are running nginx service. In order to connect to container, you could use either ID, this one, or this name. Let's connect to container by this ID. Please select this container, not pause container, and let's enter command docker exec-it. Here is ID of the container, and let's connect this container using SHA executable. Now I am inside of the container. Let's check its host name, nginx. It is name of the pod actually, and same name was assigned to this container. And let's also check IP address of this container. Here is such IP address, 172.17.03. And that's that IP address which we saw in the details of the pod. Now let's try to connect to web server which is running inside of this container where we are currently in by using this IP address. And for that we could utilize curl command and here paste IP address of this particular container. Recap that we are inside of the nginx container. Let's try to make connection, and here I see welcome to nginx page which was returned by this web server. It means that Nginx web server is up and running. Let's go out of this container. And now we are still inside of the Kubernetes node. Recap that we made SSH connection to it. And now let's exit from this connection as well, like that. And now let's enter following command: kubectl get pods -o wide. And with such option, you'll find also IP address of particular pod in this output. And here is the same IP address which we just saw inside of the container. Let's now try to connect to such IP address from our computer. Our computer is external relative to our Kubernetes cluster, because Kubernetes node is running inside of the virtual machine. And this IP address was assigned by Docker to a particular container inside of the node. Let's try to connect to such IP address. I could utilize the same command curl here, it is available on Mac, or you could simply open up web browser and connect to this IP address. And you'll find out that you will not be able to connect to Nginx container like that. Because, as I told you before, such IP address is internal IP address of the pod, and you are not able to connect to such pod from outside world, outside of the cluster. Great, that's how we created very first pod in our Kubernetes cluster, and we also explored details of such pod. And I hope that now it is clear to you what happens when you create a pod. Inside of the pod, Kubernetes creates a container, and in order to create container, it has to pull image from the Docker Hub. And in our example, Nginx image was pulled, and new container was created based on that image. Also, we went inside of the container and verified that Nginx web server is now actually running. But we are not able to connect to such pod from the outside, because now it has only internal IP address which was assigned by the Docker. But of course, creation of the pods using kubectl run command is not really convenient, because you are not able to scale and, for example, increase quantity of the pods. There is just single pod, which we created using kubectl run command. That's why now let's simply delete created pod. For that there is command kubectl delete. Next will be name of the resource we would like to delete, and it is pod, and here will be name of the pod. In our example, Nginx, because we specified such name for the pod manually when we entered kubectl run command. So let's go ahead and delete such a pod. Pod Nginx deleted. Kubectl get pods. And there are no resources found in default namespace. And such pod is simply gone. And all volumes, all namespaces related to this particular pod were removed. Great. You might notice that we entered kubectl command multiple times, and in my opinion such command is relatively long, and we are able to create alias for such command in order to save some time in the future. And we could alias kubectl command to just a single letter k. And afterwards we will enter such commands as k get pods. But now if I enter such command, I'll get command not found error, because I have not yet created any aliases. On Linux-like operating systems, you could very easily create alias by entering command alias. Next will be alias for the command, then equal sign, and after equal sign in double quotes, you could write command which you would like to alias. In our example, kubectl. If you are a Windows user and if you are using PowerShell, this command will not work there. If you want to get similar to mine experience in command line, I recommend to you to install git bash. In order to install it, please navigate to git.scm.com and simply download Git. If Git is already installed on your Windows computer, you already have access to git bash. It is another terminal. If you don't have Git installed, please go to Windows section here and download Git for Windows. Here are different links to it. And after installation, please open git bash terminal instead of the PowerShell. So, I already have alias command available in this terminal on macOS, therefore I will be able to create such an alias. Let's create alias. Alias was created, and now I am able to utilize just short version of the command k get pods. And now I see output no resources found in default namespace. From this point on, I will utilize such short version of the kubectl command. But please notice that such alias will live only during this session in the terminal. After a load of the computer or when you open up another terminal session, this alias will be gone. If you would like to create a permanent alias, of course it is possible to do. In order to perform such a task, you have to edit your shell configuration profile. But I will not do that right now. It's enough to have just temporal alias. Great, now let's continue. As I mentioned before, it is not convenient to create separate pods inside of the Kubernetes cluster, because you are not able to scale and increase quantity of the pods. Therefore, the most common way to create multiple pods when you are able to increase quantity of the pods, decrease quantity, modify configuration, etc. is by using deployments. And deployment will be responsible for creation of the actual pods. But please notice that all pods inside of the deployment will be the same, exactly the same. But you could create multiple copies of the same pod and distribute load across different nodes in the Kubernetes cluster. That's the purpose of the deployment. Now let's go ahead and create deployment, and we will utilize same image which we utilized before. It is Nginx image. And also afterwards we will increase quantity of the pods in this deployment, and also we will create a service for this deployment in order to be able to connect to our deployment from external world. Let's go ahead and create such deployment, and for that we will utilize command kubectl create deployment. We already aliased kubectl command, that's why I will enter k create deployment. And next will be name of the deployment. Let's name it Nginx. And afterwards, let's specify also image, similarly as we did in kubectl run command. And here after equal sign will be name of the image we would like to utilize for this deployment. And let's enter here Nginx. In order to avoid any confusion, let's modify name of this deployment and let's name it, for instance, Nginx-deployment. Like that. Let's go ahead and create this deployment. Deployment was created. Let's enter command k get deployments. Here is single deployment. It is ready and up to date. And let's enter k get pods. And now I see that there is now single pod which is managed by this particular deployment. And such a pod was created automatically after we created such deployment. And now this pod is managed by this deployment. There is just single pod at the moment, and of course it is possible to scale quantity of the pods and increase quantity of the pods, for instance, to 3, 5, and so on. But first, before doing that, let's read details about such deployment. And for that, let's enter command k describe deployment, and here will be name of the deployment Nginx deployment. Here are details of created deployment. Let's scroll a bit up, and here at the beginning of the output I see name of the deployment Nginx deployment. That's that name which was given to this deployment by us. Here is namespace where such deployment was created, default namespace. Below you'll see that Kubernetes automatically assigned labels to this particular deployment, and there is just single label up equal sign Nginx deployment. Also there are annotations, again created automatically. Here is annotation, and here is also selector. Selectors are used in order to connect pods with deployments, because in Kubernetes pods and deployments are actually separate objects. And we have to know how to assign specific pods to particular deployments. And here we see selector up equal sign Nginx deployment. And for particular pod which was automatically created and assigned to this deployment, we will find a label with the same value, up equals sign nginx deployment. We will have a look at that just in a minute. Also, there is replicas field, and here you could find information about quantity of the pods which are desired by this deployment and actual quantity of the pods which are running. Here is just single pod, single replica which is desired, one updated, one total, and one available. It means that now there is one pod which is assigned to this deployment. Here is also strategy type, rolling update, which tells how to perform updates of the deployments. We will get back to it a bit later in this course. And also below you'll find other details about this particular deployment. Here you'll find also details about pod template, and as I just told you, you'll find out inside of the pod corresponding label up equals sign nginx deployment. And same label is mentioned here in the selector field, in the deployment. And that's how deployment is connected to particular pods. Also, if you scroll a bit down, you'll find actual events related to this particular deployment. And here we see single event scaling replica set. But what is replica set? A bit above you see new replica set, nginx deployment and ID of the replica set. And replica set actually manages all pods related to deployment. And replica set is a set of replicas of your application, because you could create 5, 10, 100 different pods in the same deployment, and all of them are included in the replica set. And that's why here you see that such replica set was scaled up to 1, and one pod was created in this replica set. Great, these are details about this particular deployment. And now let's have a look again at the list of the pods, get pods. Here is just single pod, and notice its name. It starts with the name of the replica set, which we just discussed and saw in the output of the details of the deployment, nginx deployment and this hash. And afterwards there is specific hash for this particular pod. And if there are multiple pods in the same deployment which belong to the same replica set, you'll see same prefix here, but different hashes here for different pods. Now there is just single pod, which is ready and which is running. Also, we could get details about this particular pod. Let's grab its name and enter here describe pod, and here let's paste copied hash. And here are details about this particular pod. Let's scroll up. Here is name of the pod. It matches with this name. It was assigned to default namespace, same as deployment. Here is node where this particular pod is running right now. Here are labels of this particular pod, and I see such label as up nginx deployment and pod template hash. Notice that this hash is equal to this hash, and it matches with ID of the replica set. Also, I see status running. Here is IP address of the pod, and here I see that it is controlled by specific replica set. Replica set, nginx deployment, and here is hash of the replica set, which controls this particular pod. Also, here are details about containers which are running inside of the pod, and here is container ID, an image which was used for creation of the container in this particular pod. Also, at the end, you could find logs related to the pod as we discussed before, successfully assigned to specific node, pulling image nginx, and so on. Now there is deployment, and inside of the deployment there is replica set, and pods are managed by this deployment. Now there is just single pod. Great. Now let's try to scale this deployment and increase quantity of the pods inside of the deployment. Now there is just single pod. For that we could utilize following command. kubectl, shortly k in our case, scale. We would like to scale deployment. Let's write here deployment. Name of the deployment in our case is nginx-deployment. And afterwards, let's specify quantity of the replicas we would like to have in this deployment right now. Now there is just single replica. In order to specify desired quantity of the replicas, we could add here option replicas, and after equal sign specify quantity of the replicas. Let's say we want to scale to 5 replicas. Let's enter 5 here, and let's scale our deployment. Deployment was scaled, and now let's enter command k get pods. And I see that there are 4 new containers which are currently being created. Here is 1 pod, 2nd, 3rd and 4th pod, and this pod is still running. In a moment you should see that all 5 pods will be running. Here they are. We just scaled our deployment to 5 different replicas, and now there are 5 different pods running right now inside of our Kubernetes cluster. And notice how easy it is. We did not create those pods manually. Kubernetes scaled this deployment automatically for us. Notice that all those pods have the same prefix. It is name of the replica set all those pods belong to, and those parts are different for different pods. And again, all pods are running. Let's also read details about those pods which will include IP addresses. Let's add here option -o white, and I'll see that each pod has different IP address here, 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 here or here. And all those pods were created just on single node Minikube, because again we have just single node cluster. If you were running multiple nodes, of course load would be distributed across different nodes, and you would see that pods were assigned to different nodes. Alright, now let's try to scale down quantity of the replicas in this deployment. From 5 to, let's say, 3. Let's go back to this command, kscale deployment nginx deployment, and here let's specify quantity of the replicas as 3, like that. Deployment was scaled, let's get pods, and I see that now there are only 3 pods up and running. 2 pods were removed. Great, now let's try to connect to one of the pods, for instance this one. Let's grab its IP address, and before we already tried to connect to one of the pods from our local computer, and again our local computer is external relative to Kubernetes cluster, it is very, very important. Let's try to connect to this IP address, CURL and paste the IP address, and connection is not successful. Let's now go inside of the node, Minikube node, and try to connect to this pod, any of those pods, from inside of the node. And it will mean that we are trying to connect to the pod inside of the cluster. Let's SSH again to our Minikube node, SSH docker, add and this IP address. In your case, this IP is of course different. Password is tcuser. And now here let's CURL and enter IP address of one of the pods. Any pod works here. So let's CURL, and I was able to connect to specific pod by its IP address. Let's try to connect to another pod with another IP. For instance, let's try 0.3. I'm not sure whether I have such pod running. Yes, I have. And I also got response from such pod with such IP address. Recap that now I'm located inside of the node, and I am able to connect to pods which are running on this specific node, using IP addresses of those pods. Let's exit from this node, and again let's list pods along with IP addresses. So I was able to connect to this pod and this pod from the node. But of course such IP addresses are assigned to pods dynamically when new pods are created. And you should not rely on IP addresses of the pods if you would like to connect to specific pod. Therefore, it's not convenient to utilize such IP addresses, and you should utilize some sort of other IP addresses, which are managed by Kubernetes, and which allow you to connect to any of the pods inside of the deployment. Let me show you how to do that. In Kubernetes, you have to create so-called services if you would like to connect to specific deployments using specific IP addresses. And there are different options available. You could create so-called cluster IP, and such IP address will be created and assigned to specific deployment, and you will be able to connect to this specific deployment only inside of the cluster using this virtual IP address. And Kubernetes will distribute a load across different pods which are assigned to specific deployment. But please note that such IP address will be just a single IP address for entire deployment. And of course, it is much more convenient to use such IP address than specific IP addresses of the pods, as we just tried. Also, there is an option to create external IP addresses to open deployment to outside world. And it is possible to expose specific deployment to the IP address of the node or use load balancer. Recap that inside of the Kubernetes cluster, it is possible to have multiple nodes, and pods could be distributed across different nodes. Therefore, the most common solution is to have load balancer IP address, which will be just single for entire Kubernetes cluster for specific deployment. And you will be able to connect to your deployment no matter where pods are created using just single external IP address. But such load balancer IP addresses are usually assigned by specific cloud provider like Amazon Web Services or Google Cloud. And such assignments are managed by Cloud Controller Manager, it is a service which is running on the master node. Let's now try to create cluster IP for our deployment, and we will create for that specific service. So, we already have deployment created. Let's read details about such deployment. Get deployments. By the way, you could shorten such long word just to deploy like that. Get deploy. And here is the name of our deployment. Now there are 3 different pods which are ready in this deployment. Let's now create a service for this particular deployment. And using service, you could expose specific port from the deployment. Now we are running 3 different pods, and inside of each pod there is Nginx container. And by default, Nginx web server is running at port 80. It means that we have to expose internal port 80 from the containers to any other port outside of the deployment. And we could choose, for instance, port 8080 for this particular example. In order to expose internal port from the deployment pods, you should utilize command expose. Let's enter expose deployment. Here will be name of the deployment we would like to create service for, Nginx deployment. Here is the name of our deployment. Recap that we don't mention here pods, we work with deployments, and pods are managed by deployments. So let's expose deployment Nginx deployment. Here will be option port. Let's specify port which we would like to utilize as external port for our deployment, and let's set it to port 8080. And also we have to add here target port if port inside of the containers is different from this port which we specify right now here. And in our example right now, port inside of the container is 80. That's why we have to add here option --target port equals sign 80. So we expose internal port from the containers to external port 8080, and we do that for the deployment. Here is name of the deployment. Alright, let's expose Nginx deployment. Service Nginx deployment was exposed, and now let's list services. For that there is command get services. And now there are 2 services. First service is default system service. It is called Kubernetes. Type is cluster IP, and here is cluster IP address. And also here we see one more service, Nginx deployment. Here is name, here is type cluster IP, and here is cluster IP. And this IP address is completely different from the IP addresses assigned to the pods. This IP address is even from another network. IP addresses of the pods start from 172, and here this IP address starts from 10. And this is a virtual IP address which was created by Kubernetes. And it is just a single IP address which could be used in order to connect to any of the pods. And such type cluster IP allows you to connect to specific deployment, in our example Nginx deployment, only from inside of the Kubernetes cluster. For instance, if in your Kubernetes cluster there is database deployment, for instance, there is MongoDB database or MySQL database, and such database should not be available and accessible from outside world, you could create cluster IP service for such database deployment, and other deployments inside of your Kubernetes cluster will be able to connect to database deployment using cluster IP. But again, such deployment will be hidden from the outside world. But on the other hand, if you create any web service deployment and it should be available from outside, of course, you have to expose it to outside world using node port or load balancer. That's what we'll try a bit later. Cluster IP will be available only inside of the cluster. So, here we see cluster IP address, here it is. And here is port which was exposed by our deployment. Also, you could get list of services using short version of this command. Simply enter k get svc. It is short version of services, svc. And result will be the same. There are now two different services with those cluster IP addresses. This one for Kubernetes service and this one for Nginx deployment service. And now let's try to connect to our deployment using this service. Let's grab this cluster IP and let's first try to connect to this cluster IP address from our local computer. CURL and paste this IP address. And after colon, let's also add port, which we exposed. It is external port for our deployment. Internally, it will be proxied to port 80 on each container. Let's try whether this works on our local computer or not. CURL, and I see no response. That's what I just told you. Cluster IP address is not available outside of the Kubernetes cluster. That's behavior of the cluster IP. It is just internally available IP address. But you are able to access cluster IP from any node. And let's try that. Let's SSH to our node. Let me go back to this command, SSH docker and IP address of the node, tc user. And let's now try to connect to cluster IP from the node. And here again, let's specify port 8080. And I see a result, welcome to Nginx. And this response was provided by one of the pods in the deployment. Of course, now from this output I am not able to recognize which pod exactly answered me. But this answer was provided by one of the pods in the deployment. I could try again, and I get answer from the pods in the deployment. That's how it works. Cluster IP is just single IP, which was created as a service for a particular deployment, and you could utilize just single IP in order to connect to any of the pods. And behind the scenes, Kubernetes does all proxying of the request to particular selected pod, and it balances a load across different pods in the deployment. Alright, let's close this connection and let's now also read details about particular service. Recap that there is command kget_svc, short version for get services, and here is name of the service which we created before. Let's take this name and write now k describe service and name of the service we would like to get details about. Here is cluster IP which we just used in order to connect to this service. Also, there is external prod, and here is target prod. And here are three different endpoints. Those endpoints indicate particular pods which are used for connections to this particular cluster IP. So load will be balanced across those three different pods. And notice everywhere here port 80. It is target port for our service. It is port 80. It is default port where Nginx server is running. So 80, 80 and 80. Also here you see type of this service cluster IP. And selector here is also present up =, Nginx deployment. And that's how this service is actually connected to particular pods. All those pods also have particular label up Nginx deployment. And this label was created by Kubernetes automatically. We did not specify it, because we just created deployment using create deployment command, and we created service using expose command. Namespace here is default, same as for pods and deployment, which is called Nginx deployment. Alright, that's it for this service, and we exposed our deployment using cluster IP. And cluster IP is only available inside of the Kubernetes cluster. Now you know how to create a pod, how to create deployment, how to scale deployment, and how to create a service for particular deployment. And we utilized Nginx image, which is available at Docker Hub. And now it's time to move on to the next step in our plan, and I promised you that we will create custom Docker image, push it to Docker Hub, and afterwards create deployment based on this image. And that's what we'll do next. But before doing that, let's remove existing service and deployment in order to have clean, let's say, setup. So let's remove deployment, delete deployment, and here will be name of the deployment, Nginx deployment. And also let's delete service, delete service Nginx deployment. Like that. Service was deleted as well. Let's list now deployments, get deploy. It is short version of the deployments, no resources found. And let's list services, get svc, just single default service with name Kubernetes. We are good to go, and now let's create very basic Node.js application. There we will utilize Express web server package and create our custom web server. Plan for this next step is following. First, we will create Node.js Express web application, and we will configure web server in such a way that it will respond with the host name of the server when we connect to it using a root URL. And in such a way, we will be able to distinguish which pod actually answers specific request. We will also Dockerize such application using a Docker file and Docker build command, and afterwards push build Docker image to Docker Hub. And finally, we will create deployment using such customly built image. You could find all final project files in the GitHub repository. You'll find link to it right now here. But I highly recommend to you to create such an application yourself, even if you don't know much about Node.js and Express. And of course, I recommend to you to build your custom image and push it to your Docker Hub account. Of course, you could utilize images available under my account. They are public. It's up to you. So, let's now open Visual Studio Code. If you don't have it, please install it. I'll open it up. And here in the Visual Studio Code, please open up Embedded Terminal, press key combination Ctrl+backtick like that. Terminal was opened, and now let's create folder for our project files. I'll cd to desktop, and here using make directory command, I'll create folder K8s. Stands for Kubernetes, as you already know. Let's cd to K8s folder, and you could open any folder using code.command if you correctly installed Visual Studio Code. If such a command is not available on your computer, you could press key combination Command-Shift-P or Ctrl-Shift-P on Windows, and here enter code and select shell command install code command in path. and afterwards code command will be available from any terminal. So I have this command already available in the path. That's why I'll open K8s folder in the Visual Studio Code editor. So code dot. It will be opened in the new window, like that. Now this folder is completely empty and has no files. Let me again open embedded terminal here. It will be opened in K8s folder. And now here let's create a folder for our first project. And this folder name will be, let's say, K8s-web-hello, because we will build very basic web application which will simply respond hello from server and server name. So K8s web hello. And here in this folder we will create Node.js application. Let's here in the terminal cd to K8s web hello folder, like that. And here first we will initialize Node.js application, and in order to do so you have to install npm on your computer. If you don't have Node.js and npm available, please go to Node.js download. Here is link, download Node.js and install Node.js on your computer. It will be installed along with npm. Of course, we will not run application using Node.js on our computers. We will run application inside of the container in the Kubernetes cluster instead. But in order to initialize project locally and install dependencies, you have to use npm. So therefore, please install Node.js along with npm. Afterwards, npm should become available on your computer. I'll hide this back pane. And now here let me npm init, and I'll initialize this project, and you could add here option -y, which will skip all answers to you during initialization of the new Node.js project. So npm init -y. New project was initialized, and here you should find now package.json file with such contents, name of the project, version, and so on. And now let's install package called Express. npm install Express. It will be downloaded from the npm registry. Package was installed and package.json file was updated. Here is now dependency called Express. So now let's create index.js file in our K8s web hello folder. By the way, notice that now there is node modules folder which contains all dependencies of our project. But now it is safe to simply remove this folder. We don't need it anymore because we will not run this project locally with help of Node. So simply select this folder and delete. Alright, now we have only package.json and package log.json files. Great. Now let's create file, and we will create it inside of the K8s web hello folder. So new file, and let's name it index.mjs. Why M? Because we will utilize ES6 modules syntax, which is available in Node.js starting from version 13. And if you would like to use import statements instead of the require statements, you have to name files with extension mjs. So let's create file index.mjs, and here I will not type contents of entire application. I will simply copy them in order to save some time. So paste here. If you would like, you could of course write this very tiny application yourself. So we import Express from Express package. We also import OS from OS. OS is built in Node.js module. And afterwards we create Express application. Here is port 3000. You could specify any other port if you would like. And that's that port where our Express web server will be running inside of the container. Here we are adding a route handler for /URL, it is root URL, and we simply answer to the client with text hello from the OS hostname. Using OS package, we retrieve hostname of the server, and in the response from the server, you will see simply text message hello from the and name of the server where this application is running. So res send, we send to the client such message. And also we log it to the console. And finally, we start Express web server app.listen, and we start it at this port 3000. And when server starts, we will log to the console message web server is listening at port and here is port. I will not dive deeper into the explanations and syntax of Node.js because it is not a Node.js course, but you get an idea. We create very basic web server which will respond with such text message. So let's save changes in this file. Ctrl-S on Windows or Command-S on Mac, like that. Changes were saved. And now let's Dockerize this application. And for that we will create Docker file. Now I recommend to you to install extensions called Docker and Kubernetes. So go to extensions here and enter first Docker here. Select Docker and click Install. In my case, Docker extension was already installed. And afterwards, please also install Kubernetes extension. Find it like that and install it as well. In my case, Kubernetes extension was installed earlier. So now we are good to go. And also, in order to build actual Docker image, you have to run Docker on your computer. Before, we did not launch Docker in order to start Minikube Kubernetes cluster, but now we need Docker in order to build Docker image. That's why please go ahead and install Docker if it is not installed on your computer. Enter Docker download, go to this link and install Docker desktop, which is available for Windows, Mac OS, and also you could install Docker directly on Linux-like systems. So please go ahead and install Docker. Afterwards, please run it. I'll run it like that. I already installed it before. Now here I see icon Docker is starting. Here I see information about that. I'll wait a bit. Meanwhile, let's create Docker file inside of the K8s web hello folder. Because we are creating now separate application in the K8s root folder. So let's create Docker file here, new file, and name it Docker file, like that. Notice that Visual Studio Code recognized the type of this file and it has added the icon Docker. And here in the Docker file, let's add instructions how we would like to build custom Docker image. I'll again grab contents of this Docker file and paste here in order to save some time. And there are following instructions. We will use Node Alpine as a base image for our custom image. Here we set working directory as /up. Next we expose port 3000. Afterwards we copy two files, package.json and package-log.json, which are present here. And then we run npm install when we will build this custom image. And after npm install, we are copying all remaining files from this folder where Docker file is located. In our example, it will be just single file index.mgs. And this file will be copied to the app folder inside of the image. If you're not familiar with those steps and don't know what from, work dir, expose, and so on mean, I highly recommend you to find Docker crash course and go through it in order to understand how Docker works and how you are able to build custom images. This course is not a Docker course. So we copy all remaining application files to target folder up, and finally we add instruction cmd, that stands for command, which actually indicates which command will be executed when corresponding container based on this customly built image will be started. And we want to run npm start command. But what happens now if we enter npm start in our project folder? Let's try that. Let's save first changes in Docker file, save, and let's open up again embedded terminal. I am still in K8s web hello folder, and here in this folder there is index.mgs file, and here let's enter npm start command. And what I see missing script start. Now our application will not launch anything if you enter npm start command. In order to be able to run our application, start web server, we need to modify package.json file. Let's do that. Let's open up package.json file, and here you'll find scripts section, and there is just single default script test. Let's actually replace test with start, like that, and here in double quotes type node index.mgs. So now there will be start script, and it will essentially run using node file index.mgs. And this will start actually our Express web server on the port 3000. That's what we discussed here. Let's save changes in package.json file. Now npm start is available, and we are able now to build our image. If you want to create custom image, you need to utilize docker build command. And usually this command is entered in the folder where Docker file is located. That's this folder in our example here. And if I list files and folders here, I'll find Docker file. And Docker file contents are here. From workdir, expose, and so on till cmd. Now, let's build Docker image, and also we will add tag to this customly built Docker image. And tag will include also username of your account at Docker Hub. If you don't have Docker Hub account, please go to hub.docker.com and create account. I already have account, and here is my username. Please create your account and choose your username, and afterwards you will be able to push repositories to Docker Hub under your account. And when you push repositories, you will find them here in the repositories section. Now, under my account, there are no repositories in this namespace. So, let's go back to Visual Studio Code, and here let's build custom image for our application. Let's use command docker build. Next will be path to Docker file. I'll use simply dot, because now I'm inside of the folder where Docker file was created. So docker build dot. Next, let's add tag to our image using -t option. Then will be username of your GitHub account. In my case, I'll type mine. And after slash, I'll give name to the repository. Let's name it same as we named this folder. K8s-web-hello. Like that. Let's build this image using docker build command. Building image. Notice that in my case, base image was already present in the cache, and other layers were also cached, and finally image was built. Now if I enter command docker images and add grep, and here will be K8s web, I'll find image that is now available in our local images repository. Here is name of the image, which we just built. Tag is latest, because in this command, which I just entered, I did not specify tag, which you are able to specify after colon here. But I built image with latest tag. So that's why tag here is latest. And here is the ID of the built image and size of the image. Now let's push this customly built image to Docker Hub. In order to do so, you have to first log in to Docker Hub. For that, please enter command docker login. I already logged in before, that's why Docker utilized cached credentials, and login succeeded. In your case, if you enter Docker login for the first time, you will be prompted to enter Docker Hub login and password. Now I am able to push this built image to Docker Hub. For that, I'll utilize command docker push, and here will be name of the image which I would like to push to remote repository hosting service. Bistashuk K8s web hello. Let's go ahead and push it using default tag latest, pushing different layers of the image. It takes some time because image is relatively large. So you see waiting for those layers. And finally, this image was pushed to Docker Hub. Let me verify that it appeared here. Refresh page. And now there is K8s web hello image. Wonderful. This image, by the way, is public and you are able to utilize it as well for your Kubernetes deployments. Image is ready and available at Docker Hub, and now we are able to create a Kubernetes deployment based on this image. Let's do that. Let's go to terminal here and let's create new deployment. By the way, now there are no deployments, k-get deploy, no deployments, k-get svc services, no services, just single one Kubernetes, it is default one. And now let's create new deployment based on customly built image. For that, let's first utilize same command as we used before, k-create deployment. K-create deployment. Let's name it K8s web hello. And the next will be option image. And image will be b/chuk in my case, slash K8s web hello. Same name as it appears here when I pushed this image to the Docker Hub. And same name as I see here. So here is my username and here is name of the Docker repository. Let's go ahead and create deployment based on this image. Of course, if you performed all steps yourself and pushed customly built image to Docker Hub under your account, you could utilize here your username. So let's go ahead and create new deployment. Deployment was created. Let's k-get pods. Now I see that container creating status is status of this pod, which was created for this deployment. Let's check again. Still container creating, because it takes some time to pull image from Docker Hub. And now I see that container is running. Great. Here is name of the container and here is hash of the replica set which was created by deployment, and here is specific hash for this particular pod. Now let's create service using cluster IP and try to connect afterwards to our web server which is running using Node.js Express. So let's create service. For that we will expose pod k-expose deployment. Here will be name of the deployment K8s web hello. Next let's add option port and recap that our Express web server is running at port 3000. Let's go back to our application, go to index.mgs file, and here is this port 3000. And we could basically expose it to the same external port that will be used for connections to deployment. Let's utilize for that just single port. We will not need for that target port option. That's why let's add --port equals sign 3000, like that. And this will create cluster IP for deployment K8s web hello. Let's go ahead and create service. Let's list services k-get svc. And here is newly created service. Here is name of the service and here is cluster IP which was created by Kubernetes. And again, using such IP address, we will be able to connect to our deployment. It means that you could connect to any of the pods. You don't select which pod you will be connected to. Kubernetes does this job for you. And here we see that we opened port 3000, exposed port 3000. Let's try to connect to this cluster IP and port 3000. Let me copy this cluster IP, and of course I will not be able to connect to this cluster IP from my local computer. That's why let's, as usually, quickly connect to our Minikube node, SSH, Docker at this IP. 59.101. In your case, this IP is different. Here password is tcuser. And now here let's see URL to cluster IP and port 3000. That's that port which we exposed from deployment. So let's go ahead and I see message hello from the K8s web hello and entire name of the server where Express Node.js application is actually running. And that's that message which comes from the Express web server here. That's where we send it back to the client. Hello from the and name, host name of the server where this application is running. And it means that everything works perfectly. We created deployment based on the customly built image which we pushed to Docker Hub. And here a result of it, and we see response from the web server application. Wonderful. By the way, if you enter curl command like that, you will not be automatically moved to the new prompt and you will stay on this line. If you want to move to the new line, you could enter curl, then add the semicolon and add here echo, like that. And now you will be moved to the new line here in the output. Wonderful. Now we got response from the same pod. Here we see same host name as we saw here. Now let's keep this window open here and let's increase quantity of the pods in our deployment. Let's scale our deployment. I'll open up new tab in the iTerm application. You could open new terminal window if you're on Windows. I'll use key combination Command T in order to open new tab here. And here in the new tab, if I enter K, I will see error, command not found, because alias works only in this tab. That's why let's create alias once again. Alias K equals sign cube CTL. By the way, you could omit double quotes here if command consists only of single word. So let me remove those double quotes like that. Alias was created, and now let's K get pods. And here I see same name of the pod, which I saw here in the answer from the web server. Let's now scale this deployment. Recap that name of our deployment is K8s web hello. Here is name of the deployment, and now it currently has just a single pod. Let's scale it. K scale deployment K8s web hello, and I would like to scale deployment to, let's say, 4 replicas. Let's go ahead. Deployment was scaled. Let's now get pods. K get pods. Now there are 4 pods. 1 is still being created. Let's check back again. And now all 4 pods are running. All of them belong to the same deployment K8s web hello, and each pod of course has its own unique IP address. Let's get details about pods. K get pods -o white. And here I see different IP addresses of each pod. And of course they differ from the cluster IP which was created for specific service. Let's list services K get SVC. And here, as before, we see cluster IP for K8s web hello service. And each of those pods is now available via this cluster IP. And Kubernetes will decide which pod to choose for each particular request. Let's now go back to this tab where we are inside of the Kubernetes node and try to make connections to this cluster IP and this port again. Let's clear terminal here and see URL. Now I see response from this pod with such name. If I repeat command, I see response from other pod. Let's repeat command once again, and so on. I see that now load is balanced across different pods, because here I see responses from different pods. Different names appear here in the responses. Different pods serve different requests. And here are different names of the pods. That's how distribution of the load works in action. And now, using such customly built Docker image, we were able to prove that. Alright, Let's continue, and now let's modify type of the service which we create for our deployment, because now there is cluster IP which is available only from inside of the cluster. Let's go here and let's delete the current service K8s web hello. Simply take its name. Let's clear terminal and enter k delete. SVC stands for service, and paste name of the service we would like to delete. Service was deleted, k get SVC. There is no such service anymore, and if I try to connect again to deployment using cluster IP which we used before, I'll definitely get an error. So I see no response. Great. Let's now create service again, but now we will set its type to node port. Let's use same command k expose deployment K8s web hello, and here will be type which will be set to node port in Pascal case notation, node port, and let's add here port option, and port will be set to 3000. Same port as we utilized before. It is that port where our containers actually run Express Node.js application. Let's go ahead and create such service of type node port. Deployment was exposed. Let's list services k-get svc. And now there is again service with name k8s web hello. Its type now is node port. Here is again cluster IP and port. But here I see port which was specified here using port option, and also after colon I see randomly created port 32,142. And now I am able to connect to deployment using node IP address. I could get node IP address by entering minikube IP. We have only single node recap, and here is its IP in my case, and I could take this IP, add this port, and I will connect to one of the ports in this deployment. Let's do that. Let me grab this IP, go to web browser, for example, because now I will be able to connect to deployment from my computer. Let me paste this IP, and after colon, I will add this port, like that. So in my case, connection string is here. So here is IP address, it is IP address of the node, and here is randomly generated port, which was created by Kubernetes itself when we created service for our deployment. Let's go ahead and try to connect, and I see response from one of the pods. Let's refresh, and I see response from other pod with other name. Refresh again, and I see response from other pod here. That's how we are able to connect to our deployment using node port service. Also, it is more simple way to get URL for connection to this deployment by using minikube service command. Minikube service, and here type name of the service, in our case K8s web hello. Let's enter, and new tab in the web browser will be opened automatically, and notice URL here same as I just used before. IP address of the node and port which was automatically generated by Kubernetes. That's node port type of the service. Also here you could see this actual URL when you enter minikube service K8s web hello. Here is actual URL, and if you want to get only URL, you could add here option --URL, and you'll see only URL, and you could grab it and paste it anywhere you want. So that's node port service type, and it exposed the deployment at the port of the node, and here is this specific port in my example. In your case, this port will be completely different. And one more option which I would like to show you in terms of creation of the service is load balancer. Let's create a load balancer service, and for that first let's delete existing service k-delete svc service k8s web hello. Service was removed k-get svc. There is no more such service. And let's create a service of type load balancer. Okay, expose, deployment, K8s web hello. Here let's add type load balancer, Pascal case notation again, and let's add port option, and its value will be 3000, same as before. Let's create such service. Service was created, kget svc. Now I see that there is service of type load balancer. Here is cluster IP, but external IP here is pending. And you will see here pending if you are using Minikube. But when you deploy your applications somewhere in the cloud using one of the cloud providers like Amazon, Google Cloud, etc., here you will see load balancer IP address assigned automatically. But in our case, using Minikube, its behavior is similar to node port, and here we will still be able to connect to our deployment using IP address of the node. And if I enter now Minikube, service K8s web hello, I'll see connection which is made to IP address of the node, and here is again random port which was generated here. Here is this random port. Alright, let's continue and let's keep this service and this deployment in place. Recap that we have single service here which we created before. It is K8s web hello, and its type now is load balancer, and there is single deployment kget deploy, and its name is K8s web hello. And now this deployment has 4 different pods available for use. We could read details about this deployment k describe deployment K8s web hello, and here are details of this deployment. By the way, at the end here I see logs related to scaling of replica set. Initially quantity of the replicas was 1, and later we scaled it to 4. If you want, you could try to scale it to any other number if you want to do so. Above, I see that this deployment has name K8s web hello, namespace is default, labels, annotations, selector, replicas, desired for, updated for, available for. And now let's try following. Let's try to update version of the image in our deployment. Notice here that strategy type is rolling update. What does it mean? When you release new version of your application, of course you want to roll out this new version in production smoothly without any interruption of service. And Kubernetes allows that out of the box, and this is very easy. And this strategy type rolling update means that new pods will be created with new image while previous pods will be still running. So pods will be replaced one by one. And finally, in some time, all pods will be running new updated image. And now let's try that in action. We will update a bit our application and build new image with another tag, for instance version 2.0.0, and afterwards we will modify image in our deployment and see what will happen, how Kubernetes will roll out this update. So let's go ahead and do that. By the way, I don't need this step anymore, where I created SSH connection to node. Therefore, let me exit from this connection and close this tab actually, and I'll keep only one tab opened. So let's go back to Visual Studio Code, and here are contents of the index.mgs file. And we already have image available for this version of the application, where server answers us with such string. Now, let's modify this string. For instance, let's add here prefix version 2, like that. And let's now build new image with new tag, push it to Docker Hub, and afterwards modify image in our deployment. Let's save changes in this file, open up embedded terminal, and let's build image and assign another tag to it. Now image has only single tag, it is latest. So let's build new image, docker build dot -t tag bistashuk. Prepend your name if you want to push this version of the image to your Docker Hub account. So bistashuk, and here will be name of the image k8s web hello, and after colon I'll add the tag, for instance 2.0.0, like that. Let's build such image. Recap that I modified index.mgs file and I updated this string. So it should build new image. Let's go ahead and build it. Building. Exporting layers. Image was built, and now let's push it to Docker Hub. I'll copy this name, including a tag. And now here I enter docker push, and new version of my application will be pushed using separate tag for the same k8s web hello image. So let's go ahead and push. Pushing. I see that some layers already exist and only one layer was pushed. So image was pushed successfully. Let me verify that. Go to my Docker Hub account, refresh. I still see just a single image. Here it is. Let me click on it. And here I should find two tags, latest and 2.0.0. Now let's deploy this new version of this image. And for that we will utilize following command. Let's go to the terminal here and let's set new image for the deployment. Set image. We are setting new image for particular deployment. Next will be deployment. Name of the deployment k8s web hello. And afterwards we need to select pods where we would like to set new image. Here we will write k8s web hello, and after equal sign we will specify new image. In my case it is bistashuk / k8s web hello colon 2.0.0. That's new tag which was assigned by us before we pushed the new version of the image to Docker Hub. After entering this command, image will be changed and rollout update will be started. Be ready to enter following command after this one. K rollout status deployment k8s web hello. You could prepare this command somewhere in the text editor and afterwards quickly paste it after this command. I'll try to enter it manually. Let's go ahead and change image. Image updated. K rollout status deployment k8s web hello. Waiting for deployment rollout to finish. And now I see the deployment successfully rolled out. And before I saw such messages as 3 out of 4 new replicas have been updated, 1 old replicas are pending termination, and so on. Finally, all previous replicas were terminated and new replicas were rolled out. Let's now list pods, get pods, and now I see that there are 4 pods. And notice age of those pods. From 30 to 40 seconds. It means that previous pods were fully terminated and new pods were created. And now in all those 4 pods we are running new version of our application. And we could verify that very easily by accessing our deployment using service. There is still service kget-svc. Type of it is load balancer. And here is cluster IP, here is port, and by entering command minikube service k8s web hello, I could open connection to one of the running pods. So let's go ahead. Connection was opened and now I see response which includes version 2. That's how rolling updates work. You could refresh page here and you should see response from other server, for instance this one. And again here I see version 2. It means that our new application version was successfully deployed to all pods in the deployment. Wonderful. That's where rolling updates, and that's how you could check status of the rolling update by entering command k rollout status. This one. If you would like, you could create one more tag for your image, push it to Docker Hub and verify how rollout works again. Or if you want, you could roll back to previous version. By the way, we could quickly try that together. Let's go to this command, and here I will remove tag, and it will mean that I would like to utilize latest tag, and let's check how image will be modified again. And we are actually going back to previous version of our application. Let's modify image. Let's check rollout status. 2 out of 4 new replicas have been updated. Waiting for deployment rollout to finish, and finally deployment successfully rolled out, and again I will see 4 completely new pods. Okay, get pods. Here is age of those 4 pods. Let's connect to our deployment again, minikube service k8s web hello, and I again see hello from the server without version 2. That's where rolling updates. Wonderful. Now let's try following. Now we have 4 pods up and running. But what happens if I simply delete one of the pods manually? Let's try that. Let's take, for example, this name of the pod, notice age of those 4 pods, and enter k delete pod and paste name of any pod you like. And after this command, let's k get pods again, and I will see that new pod will be created automatically, container creating. Because we told Kubernetes that desired quantity of the pods in the deployment is 4. That's why it tries to do all its best to create desired quantity of the replicas in specific deployment. And now I will see that there are 4 pods again up and running, and age of this pod is 33 seconds. Alright, we tried rolling updates, and also we tried to delete one of the running pods, and now let me demonstrate to you how to launch Kubernetes dashboard. If you are using Minikube, it is very easy, just single command. But if you are running Kubernetes on your own premises or somewhere in the cloud, it could be a bit more difficult, because you need to secure web access to dashboard. But here again, it's just single command, minikube dashboard, like that. Let's enable dashboard, launching proxy, verifying proxy health, and dashboard web page will be opened here. And as you saw here, no prompt for username and password. This dashboard was simply launched like that, because we are using Minikube. And here you could observe details about your Kubernetes cluster. For example, you could go to deployments and you will find single deployment. Here it is. Let me decrease a bit font size like that. So here is metadata for this deployment. Here are labels, strategy rolling update. That's what we observed. Pod status for available, for updated. Here are conditions, new replica set. Here is ID of the replica set, which was created by this deployment. You could click on this hyperlink and read details about specific replica set. Notice that replica set, deployment, and pods all belong to the same namespace default. But of course, you could assign deployments to different custom namespaces. Labels for this replica set, pod status for running for desired, and here are links to all pods which belong to this particular replica set. Also below there is service which was created for this replica set. For this deployment, type is load balancer here. And if you click on specific pod, you could read details about particular pod. Here is name of the pod, namespace, when pod was created. Here is information about the node where this pod was created, status is running, IP address of the pod. Below you could also find details about replica set, which actually controls this particular pod. And notice that the label for this pod is here, up:k8s web hello, and the same label is found here, controlled by replica set, and here is label in the replica set. Also below you might find details about events which happened in this particular pod. For example, here is step pulling image bistashuk k8s web hello. And here are details about containers which are now running inside of the pod. There is now just a single container inside of each pod. By the way, if I go to replica sets, I will find actually two different replica sets, which were created for different images, for this image and for this image. And now in this replica set there are 0 pods, because we rolled back from this image to this image with tag latest. That's why now here I see 4 pods and here are 0 pods. Alright, that's graphical user interface. You could click on other menu items and observe which, for example, nodes belong to the cluster. Now there is just single Minikube node. And if you click on it, you could read details about this particular node. That was Kubernetes dashboard, and you could utilize it in order to observe status of the Kubernetes deployments and services and so on. Let me close it, and now let's continue, and let's Ctrl+C in order to interrupt this process here, and now Minikube dashboard will not be available anymore. Now, important notice, we just used imperative approach to creation of the deployments and services. And we created deployments and services using different kubectl commands. But usually that's not the way how deployments and services are created. And in most cases, declarative approach is utilized. And in declarative approach, you have to create YAML configuration files which describe all details for deployments and services, and afterwards apply those configuration files using kubectl apply command. And that's actually declarative approach of creation of different resources and objects in Kubernetes. And that's what we will do right now. Let's now delete both deployment and service which we created before. And for that, you could utilize command kubectl delete deployment and afterwards delete service. But there is also short version of deletion of all resources in default namespace, and it is kdelete all with option --all, like that. All resources will be deleted. You see that pods were deleted, service was deleted, and deployment was deleted as well. Let's get pods. Pods are still being terminated. Let's check again. Still terminating. Let's wait a bit. And now there are no resources found in default namespace. All pods were terminated. Let's get services, get svc. And now there is only single default system service, Kubernetes. And of course there are no deployments, get deploy. No resources found. Now let's create YAML configuration file for deployment and for service. First, we will create two separate configuration files. Let's go to Visual Studio Code, and here let me, by the way, hide embedded terminal for the moment, and let me close those all windows. And now here let's collapse this folder k8s web hello, because this folder was dedicated to our Node.js Express web application. And now here in the root of the k8s folder, here, let's create following files. Deployment.yaml. And also let's create file service.yaml, like that. So two files, deployment.yaml and service.yaml. Let's first fill in deployment.yaml file. If you installed Kubernetes extension here in VS Code, what I asked you to do before, you could create such configuration files very fast. Let me show you. So type here simply deployment, and you will see suggestion Kubernetes deployment. Let's select it, and you will see that YAML configuration file will be created automatically for you. And you will see that all appearances of the My App will be highlighted, and you could simply type name of the deployment which you would like to set. And let's set name to K8S, same as we did before, but now we are using YAML configuration file, so K8S web hello, like that. Deployment name was set. Here is actual name for this deployment. Here is API version apps/v1. Here is selector with match labels key, and by this match labels key we specify which pods will be managed by this deployment. And below there is nested template, and this template describes actually pod. But here you don't need to specify kind of the template, like that, because this nested template for deployment template is always pod. Therefore, kind here is not needed. Next, for the pods which belong to this deployment, here we set labels, and label here is the same as label here in selector, match labels. So this label and this label match here. And next, in spec key, we specify which containers we want to create in this pod. And there is just single container with such name. Image is to be filled. We will replace this image placeholder now with real image. And also below you could specify which ports you would like to open in specific container. And below in the ports section you could specify list of the container ports which will be open on the pod's IP address. So let's fill now details in this spec section. Image will be bistashuk /K8S web hello, and the ports here will be container port 3000, like that. Also notice that VS Code Kubernetes extension added resources section here, and in this section there is limits key which specify memory and CPU limits for each pod which will be created by this deployment. And here we limit amount of memory and amount of CPU resources. 500 M means half of the CPU core. If you want, you could modify 500 to 250, for example, 1/4 of the CPU core. Let's keep it like that. And that's it for this specification of the deployment. Let's save changes in this file. And now let me actually show how to find documentation on how to create specific YAML configuration files. Let's go to web browser, and here let's go to kubernetes.io and go here to documentation, and here go to reference, and here select Kubernetes API. And in Kubernetes API you could select, for example, workload resources. And you will find details how to describe, for example, pods, or create pod template, or create replica set. We just created deployment, therefore let's click on deployment section here. And you will find details how to create YAML configuration files if you want to create deployment. API version must be set to apps/v1. And below you will find other keys which must be present in deployment configuration file. For example, kind must be set to deployment. Then there is metadata section, spec, status. Status, by the way, is filled by Kubernetes automatically, and it will be added after you create deployment based on specific configuration file. And if I go back to configuration file here, I will find such keys as API version, kind, metadata, and spec. Same keys which are described here: API version, kind, metadata, and spec. And if you want to get details about deployment spec, you could click here, and you will find that inside of the spec you have to specify selector, template, replicas, strategy, min ready seconds, and so on. And if I have a look at this spec here, I will find out that inside of spec, in this example, there is selector and template. Selector and template here. and both are required. If you click on template, you will read details about pod template spec. Let's click on it. And here you will find that inside of the pod template spec, you have to specify metadata and spec, which is pod spec. And that's what we added here in the template section. Metadata and spec for the pod. Let's click on pod spec and read details about pod specification. Containers is required, and you could add multiple containers in the pod specification if you want to do so. And here in this spec we have containers. Here it is. Let's click on container here. And in this container specification you will find name which is required. That's why we set name as this. Also you have to set image for specific container. Here is image. Resources and ports are also described here on this documentation page. So here is ports section. Also you could set, for instance, environment variables for a particular container. I highly recommend to you to get familiar with documentation and with all options available. And I just demonstrated to you how you could dig through documentation and find out how to fill different sections of the configuration file. Alright, we are done with creation of the configuration file for deployment. So kind here is deployment. And let's now apply this configuration file using declarative approach. Having such file in place, you will no longer require to enter command kubectl create deployment. You will just enter command kubectl apply. Let's do that. Let's open up embedded terminal here. And now I'm still inside of the K8s web hello folder. Let me go out of this folder where this deployment YAML file is located. Let's list files here. So here is deployment YAML configuration file. And here let's enter command kubectl apply -f stands for file. And here will be name of the file, deployment.yaml. Simple as that. File was applied and deployment was created. Let's check that. By the way, here I don't have alias. Let's add quickly alias k kubectl. So k get deployments. And now there is k8s web hello deployment. And there is a single pod in this deployment, k get pods. Here is this pod which is up and running. Great, but how we could now scale this deployment and increase quantity of the replicas? Very easily, by modification of this specification file. But how we could increase quantity of the replicas? Here at the moment we don't see any numbers. Let's try to find out that using documentation. I assume that I don't know how to change that. So let's go to workload resources. Check deployment and scroll down here. So spec, status, metadata kind, no options here. Let's click on deployment spec. Here is selector, template, replicas, number of desired pods. And that's that option which you need to utilize if you want to modify quantity of the replicas from default number 1. So here is default number 1 to any other number. And you have to add replicas key in the deployment spec. So let's go to deployment spec. So here is spec. And here let's add new key, replicas. And its value will be, let's say, number 5. If I go back, I could read that its value is integer 32. So you don't need to write here file like that. Write as a number. Let's save changes and let's apply this deployment YAML configuration file again using same command kubectl apply -f deployment YAML. Let's go ahead, configure it, k get pods, and now I see that 4 new containers are being created. And now my deployment has 5 different pods. 4 of them are already ready. Now 5 are running. That's how we were able very easily modify our deployment simply by modification of the deployment YAML configuration file. But of course, now there are no services get svc. Let's create new service using similar approach. Let's hide embedded terminal and let's now go to service.yaml configuration file. And here let's also speed up the process for creation of the service configuration file and type service, and Kubernetes extension will offer us this option, and this spec will be created automatically. Kind is service, API version is v1 here, it differs from API version for deployment kind. Metadata name sets name for this service. Let's enter name K8s web hello. And also here let's modify selector, and selector will be up K8s web hello as well. By the way, if you hover mouse over any of the keys in this configuration file, you could find hyperlinks to documentation for each particular key. For example, key name URL is here. Or if you hover mouse over kind, you could also find hyperlinks here for API version, for kind, and metadata, for instance. Alright, what is left here in this service is modification of the ports section. Here I see that port and target port were auto-populated. Before we exposed actually same port 3000, which is the port where our Express web server is running. And now we could try different port, expose port 3000, which is target port, to port, let's say, 3030, like that. And it means that target port 3000 will be exposed to external port 3030. Also notice that in this specification there is no type for this service. And let's say that we want to create load balancer service. For that, let's go to documentation. Let's find documentation for service here, Kubernetes API, service resources, service, and here let's click on service specification. Here is selector, ports, and also below you could find type of the service. Type, either cluster IP, which is default, or external name, or node port, or load balancer. Let's set type to load balancer. Let's go back to our configuration file, and here in spec, let's set type to load balancer, like that. That's it for this service specification. Let's save changes in this file, and let's apply this using same command as before. kubectl apply -f stands for file, and here type service.yaml. I'm still inside of the K8s folder. So let's apply service YAML file, applied, kget svc, and now I see that new service with type load balancer was created. And now, similarly as before, I could open connection to our deployment using command minikube service K8s web hello. Let's go ahead, and page will be opened. Refresh, and I got response from another pod. It means that now everything works as before. There is now service and deployment. And we created everything using a declarative approach, using configuration files. Here is file for service, and here is file for deployment. We could also very easily delete deployment and service which we just created using just one command. Let's do that. Go to the terminal and here enter k, delete, -f. Here will be name of the first file, deployment YAML, and here let's add -f option once again and type service.yaml. Let's go ahead and delete both deployment and service. Let's check. Kget svc, no service, kget deployment, and no deployment. Great. Now let's do following. Let's try to create two deployments and let's connect them with each other, because it's a very common task when you want to connect different applications together. For example, connect front end to backend, or connect backend to database service, and so on. Therefore, now we will do following. Let me draw a picture. So similarly as before, we will create a web deployment and deploy there our Node.js Express web application. And here let me type web, like that. And also we will create one more deployment, and we will name it Nginx. This Nginx deployment will run basic Nginx image with no adjustments. And this Nginx deployment will have corresponding service with cluster IP. So let me draw here a line, and here will be cluster IP. Let's start with capital C, cluster IP, like that. And those two deployments, of course, are located in the Kubernetes cluster. And this deployment will be also exposed, but its service will have type load balancer. It means that we will be able to connect to it from outside using load balancer's IP address. So here is load balancer. Now, inside of the web application, we will create two endpoints. First will be root endpoint, same as before, which will return simply hello from the web server. And one more endpoint here will be, let's say, Nginx. And when connection will be made to Nginx, we will connect to Nginx service by using cluster IP, or you will see that using Nginx service name. Like that. So from one deployment, we will connect to another deployment and get response from one of the pods which will be running Nginx application. And afterwards, we will return back result to the client with the contents which we received from the Nginx pod. So that's the plan. And in such way, we will actually connect two different deployments, web deployment and Nginx deployment. Let's get started with that. Here inside of the K8s folder, let me close those files for the moment, let's create a copy of this folder, K8s web hello, which contains all files related to our Web Express application. Let's copy this folder and paste here. And let's rename it. Simply click on this name, press enter, and enter a new name, K8s web 2 Nginx, like that. Next, let's keep Docker file unmodified. Here are contents of this Docker file in this folder, so no modifications here, but we will slightly modify index.mgs file, and I will grab modified file from here. Let me copy it and paste here. So here are contents of index.mgs file for this second application. There is still root URL here, /. We still create Express web server, but we add here one more endpoint, Nginx. And its route handler is now async function, because now we will connect to another server, simulating connection between different deployments. And notice URL here. It is simply http://nginx. And we will create a service called Nginx for second Nginx deployment. And from this deployment, we will be able to connect to another deployment using just name of the corresponding service. Simple as that. Of course, it is possible to connect using either cluster IP, but cluster IP is dynamic. Name of the service is static. So we will connect to one of the Nginx servers by using Nginx service name. And here we utilize fetch, which we import from node fetch package. By the way, in a moment we will install it in this application as well. So we are awaiting for response from the Nginx server. And afterwards we take body from the response, calling text method, and simply return to the client this body. Essentially, what this endpoint will do, it will simply proxy request to the Nginx server and return response from the Nginx to the client. Simple as that. And here we import fetch from node fetch, therefore we have to install such external dependency. And for that, let's open up embedded terminal and here make sure that you cd to this folder k8s web2nginx, web2nginx. And here let's enter npm install node fetch. Installing package. You will see that this package, the JSON file, will be modified. So now here are two dependencies, express and node fetch. Dependency was installed, and notice again that node modules folder has appeared here, but we don't need it here. Let's simply remove it, because inside of the image which we will build right now, we have instruction to run npm install. Here it is. That's why all necessary dependencies will be installed inside of the Docker image. Alright, now we are good to go. By the way, this application is also included in the final project files, which you could clone from my GitHub repository. So k8s web2nginx, and here is index.mgs file. And now let's again build Docker image, but it will be new Docker image from this application. And now let's build it using same command as before, docker build. So let's list files and folders here. There is Docker file. Docker file was not modified. It is the same as for previous application. And now let's build Docker image. Docker build dot, and let's add tag bistashuk slash, and let's name it k8s web2nginx. Same name as for this folder. And let's keep tag as latest. You don't have to add here tag like that in this case. It will be added automatically. So let's build such image. Image is being built. Notice npm install command. Image was built, and now let's push it to Docker Hub. Let me grab this name. Docker push. And here will be name of the image which I want to push to Docker Hub. Pushing. Some of the layers will be reused from other image. And finally, image was pushed, and now we are able to utilize it in Kubernetes deployment. Great. Let's hide terminal, and now let's do following. Now I would like to demonstrate you how you could combine deployment YAML and service YAML configuration files just in one file. Let's close those files and let's create a new file, and let's name it k8s web2nginx.yaml, like that. Now in this configuration file, we will combine instructions for creation of the deployment and service. Let's first go to service.yaml, take contents of this file, and paste here in the k8s web2nginx YAML. Afterwards, please add 3 dashes, exactly 3, and go to the next line. Now let's go to YAML file for the deployment. Let's take all its contents and paste here under those 3 dashes. And now just in single file we have specification both for service and deployment. Now let's modify deployment because we would like to utilize other image, and here we will utilize other name. By the way, we could select this name here, then right button click and select change all occurrences. And let's name service and deployment as k8s web2nginx, like that. Let's keep type for this service as load balancer. Port here could be modified to another. For instance, let's set it to all 3, like that. And here in the deployment specification, let's decrease quantity of the replicas to, let's say, 3. And also let's modify specification for containers. And the image which we would like to use right now will be k8s web2nginx. It was replaced when I modified the k8s web hello name. So here is correct image which we just pushed to Docker Hub, and this image we would like to utilize for this particular deployment. And container port will be unchanged, it is 3000. Alright, that's it for specification for deployment and service for new application. And now let's create a specification for Nginx deployment and service, because we will deploy now two different applications. One which will be based on our custom image, and second which is based on official Docker image called Nginx. Let's simply copy this file and paste here, and let's name this file as nginx.yaml. And now in this nginx.yaml file, let's modify names. Let's again select this and change all occurrences, and let's name it simply Nginx. Please type exactly as I just did. Exactly Nginx. Because this name for this service we will utilize inside of other deployment, inside of our containers which are running Express Node.js web server. We will connect to this deployment by using Nginx service name. That's why this name is very important here. Now, we decided to utilize cluster IP service type for this second deployment. That's why let's remove type load balancer from here. By default, cluster IP will be assigned here. And let's modify ports section here. Let's remove target port and keep only port and set it to 80. It is default port where Nginx will run web server. Also in the deployment section we have to modify image, and now it will be simply Nginx without your username, because we would like to utilize default Nginx image. Let's keep resource limits here in place, and let's modify here container port to 80, like that. So quantity of the replicas will be, for instance, 5 instead of 3. Let's save changes here and let's summarize what we did here. We will create a new service called Nginx, and name here is important for our setup. Here is a ports section with single key port, and it means that the external port 80 will be mapped to internal port 80. It is port where Nginx web server is running by default. And the service type here is cluster IP. It means that such service will not be available outside of the Kubernetes cluster. And here in this deployment, we utilize official Docker image called Nginx. Here is specification for the pod containers, and container port is set to 80. That's it. So we created two YAML configuration files, nginx.yaml and k8s web to nginx, which utilizes customly built image. Here is this image name. And now let's apply both configuration files, this one and this one. Let's go to the terminal and verify that now we don't have any deployments. Get deploy. No deployments at the moment and no services. And now let's deploy everything using just single command. Now I am still inside of the k8s web to nginx folder. Let's go one level up where our YAML configuration files are located. Here they are, this one and this one. And let's apply them. K apply -f. Here will be first file. Here is its name. And we could also apply one more file, -f nginx YAML, like that. Let's go ahead and create both deployments and both services. Service created, deployment created, service created, and deployment created. Let's check deployments, get deploy. There are now two deployments, this one and this one. Partially they are ready. Get svc. Let's read information about services. There are two services which were created. This one, which has type load balancer, and nginx, which has type cluster IP. Recap that we will connect from this web to nginx deployment to nginx deployment using this name for the service. Or we could also utilize cluster IP in order to connect from one deployment to another. But cluster IP is dynamic. This service name is static. So let's also check pods. Get pods. Some of the pods are running and one is still pending. And now we are able to test our setup and try to connect from web application, from web deployment to Nginx deployment. Let's open connection to our web service deployment because we used here load balancer type for this service, and we could utilize this port here and IP address of the Kubernetes node. Recap that in order to quickly get URL for specific deployment using Minikube, you could enter command minikube service, and here will be name of the service, K8s web to Nginx. Web browser page was opened and we got response from one of the pods which belongs to K8s web to Nginx deployment. And here is name of the corresponding replica set. Alright, we just triggered connection to root URL. Let's go back quickly to our application. Let me hide this terminal here and let's go to this new application and open index.mgs file and recap that here we have two endpoints, root endpoint and /nginx endpoint, which will essentially send request to nginx URL, this one, and return back to the client proxied response from other server. So this server is external relative to this server where we are running this web application. We just received this string from the server. Let's now try to connect to Nginx endpoint. Let's go back to web browser and add here /nginx, press enter, and what I got? I got welcome to Nginx. It means that the response from the Nginx server was proxied successfully inside of the server which belongs to our web deployment. And we were able in such way to connect from one deployment to another deployment by the name of another service. So Nginx here is name of another service as we specified here. And such service has now cluster IP. Get SVC. So here is cluster IP for Nginx service. And we were able to connect to another deployment by name of the service. That's how you could very easily connect different deployments together. And such a resolution of the service name to IP address is performed by internal service of the Kubernetes, which is called DNS. And we could actually verify that quickly. Let's go to the terminal, for example, here, and recap that we could still get here list of the pods, get pods. And now we could take any of the pods and execute any commands inside of the running container inside of the pod, using kubectl exec command. This command is very similar to docker exec command. Let's now take a name of any pod which belongs to K8s web to Nginx deployment. Let me copy this name. In your case, names will be completely different. And let me clear a terminal here and enter k exec. Here will be name of the pod. Next will be 2 dashes. And afterwards, let's type ns lookup Nginx, like that. Let's press enter. And I got following response. What does it mean? Using this command, we tried to resolve Nginx name from inside of the container which belongs to this pod. And such resolution was successful. And that's IP address which I got from the DNS server when I made request nslookup Nginx. But where does this IP come from? Let's write k get svc. And here I get such IP. And notice that this IP is the same as this one. And that's what I told you. Now Kubernetes is able to resolve name of the service to corresponding cluster IP. And that's what we see here. And we performed resolution inside of the pod which belongs to other deployment and other service. And of course, I could execute similarly command in one of the pods. For example, I could type here wget -q o- and here type HTTP nginx. And this will actually connect to nginx server and retrieve from it root web page. Let's try that. And I successfully received response from one of the nginx pods. And here is nginx web page. Alright, that's how different deployments could be very easily connected with each other. Let's go back to Visual Studio Code and let's delete everything what we have so far. If you want to dive deeper and explore details about those deployments, you could do that, of course, now. You could launch, for instance, Minikube dashboard, you could dig deeper, go to different pods and explore what happens inside of them and so on. You have all necessary knowledge for that. Alright, now let's delete both deployments and both services. Okay, delete -f nginx.yaml and -f k8s web to nginx.yaml. Let's go ahead. Both services and deployments were deleted. K-get deploy, no resources found, K-get svc, just single service. I think you would agree with me that deployment using YAML configuration files is much more pleasant and faster than deployment using separate kubectl commands. We are done with main practical part of this course and one step left, and I would like to demonstrate to you how to change container runtime, which is currently Docker in our Kubernetes cluster, to other container runtime, for instance CRI-O or containerd. And in order to modify container runtime, we need to delete current Minikube setup and create new one. For that, let's go to the terminal here and let's enter Minikube status command. Now it is running, kubelet is running, API server is running. Let's now stop Minikube. Minikube stop, stopping node Minikube. One node was stopped, and now let's delete current setup, Minikube delete. Deleting Minikube in VirtualBox in my case. Removed all traces of the Minikube cluster. Now let's create cluster over again. Minikube, start. I will again use driver option, and its value will be VirtualBox in my case. If you're a Windows user, you should type here Hyper-V, same as for previous Minikube start. But please notice that Docker option did not work for me at least. I wasn't able to run CRI-O containers inside of the Docker container. So for some reason it didn't work. Therefore, I utilize VirtualBox and I don't recommend you to use now driver Docker. So driver is VirtualBox in my case, and next I will add option --container -runtime, and its value will be CRI-O. One more option is containerd. You could try both if you want to do so. So I will enter here CRI-O like that, and let's create a Minikube cluster from the scratch once again. But now container runtime is set to CRI-O. Let's go ahead. Starting control plane node Minikube in cluster Minikube, again creating VirtualBox. It will take a while. Now I see step preparing Kubernetes on CRI-O. And finally it was done. Let's now check status, Minikube status. Type control plane, host is running, everything is running same as before. But now container runtime inside of the node is CRI-O. Let's check that. Let's SSH to Minikube IP address, and let's enter here first Minikube IP, SSH docker at 192.168.59.102. Yes. TC user. Now I'm inside of the Minikube node, and now let's enter docker ps. And what I see cannot connect to the Docker. And it is an indication that Docker is not running inside of this node, because we are using CRI-O container runtime instead. But how to check whether there are CRI-O containers? Very easily, using following command: sudo CRI-ctl ps. And here are a bunch of different containers which are running, like kubeproxy, core DNS, storage provisioner, and so on. Now let's try again to deploy both applications, web application and Nginx application, and create both services and see how it goes. Let's go back to Visual Studio Code, and here let's perform same task as before. Simply apply configuration. Okay, apply -f and apply both YAML configuration files. Let's go ahead. Created deployments and created services. Okay, get deploy. Not ready yet, but there are two deployments. Once again not ready. Let's get information about services. There are two services, same as before. Okay, get pods. Some of the pods are in status container creating, one is pending. Let's check again. Some are already running. Okay, get deploy. First deployment is ready. Nginx is not yet ready. Let's check again. Now Nginx is partially ready. And now all those containers were created by CRI-O container runtime. Let's enter Minikube service and name of this service in order to test whether everything works as before. So here is response from one of the pods. And let's add here /nginx. And same as before, it works. Now we were able to proxy response from the Nginx deployment. Wonderful! We just modified the container runtime, and now it is set to CRI-O. Let's go back to this SSH connection where we connected to node. And here let's enter again sudo CRI-ctl ps, and let's, for example, grab by the name k8s web to Nginx. And I see now three different containers which belong to this deployment. And now they are running using CRI-O. Alright, let's now disconnect from this server. Alright guys, that's it for this Kubernetes for Beginners course. You could of course keep your Minikube cluster running, you could create other deployments, you could build other Docker images. In other words, play with Kubernetes as you want and get familiar with all Kubernetes tools which we discussed in this course. I hope you enjoyed this course, and I hope you enjoyed spending time with me. If so, you could find me in social media networks, all links you find here on the screen, and I will be more than happy to meet you in other videos. And I wish you all the best. Bye bye.